Now here's, I think, coming to your question, the first point I want to make is that the striking fact is that I told you just right now all these rates of return, 20% per month. 20% per month, you should just put it in your calculator and see what that implies per year. That's something, I think it's 600% per year compounded. It's a huge number. Now somehow that something that doesn't add up to that is the following. The IMF does one very useful thing. Maybe it does many useful things. I don't want to say, I'm skeptical, but maybe it does at least one useful thing. It produces what they call the ICAR for every country, the incremental capital output ratio. What's the ICAR? The ICAR for every year, it takes GDP, change in GDP, change in the capital stock as measured by the country, basically investment. This is total investment, and this is total change in GDP, and it divides them, and it puts a table. Now this number is useful because we could invert this number and write it as that. Okay. Why do I want this number? What does it look like? The marginal product of capital. It looks exactly like the marginal product of capital. In fact, it's not the marginal product of capital because, of course, K is not the only thing that changes. And these are not marginal changes, they're non-marginal changes. Human capital changes, labor force changes. But that means that this number, this ratio here, I'm attributing all the change in GDP to capital here. So this has to be an upper bound on this. Okay, that's why I like that number, because it gives you an upper bound. So if you just look at year after year after year, countries are adding capital, the GDP is changing, and you can kind of look at that, and when you look at that, you see that that must be, so this must be strictly bigger than that. That's just arithmetic. I didn't do any deep economics there. Okay? But if you believe me on that, then I can use this to bound that. This is the number for the whole economy, not the number for an individual firm. It's just what happens the whole economy. And the answer from there is that number is 4.5 for India, 3.7 for Uganda, etc. You can do it now. It's these numbers are a bit higher in both countries. If you invert that, you get numbers like 22% in this number here is for India is 22%. Actually lower now. What is this number? This number gives you an upper bound on the average marginal product. That's an idea that you probably haven't heard, maybe have not heard before. It's the average marginal product. That's confusing because usually we take the average and the marginal product as meaning two different things. The average product, the marginal product. This is the average marginal product. The average marginal product is the capital weighted, meaning different firms add different amounts of capital in a given year. This takes the marginal products of all those firms, weights them by the marginal product by the amount of capital they added. That weighted average is the average marginal product. That's what we observe in the data. What we observe in the data when we invert the ICAR is an upper bound on that, but it's really not the upper bound on an individual firm's marginal product, is the upper bound on the average of that. I add capital to different firms. Some firms' output goes up by 50%, others goes up by 30%, etc. And I take the average of those things and I get the average marginal product. That's what we are picking up with this number. Is that clear? So we know that the average marginal product is bounded above by 22%. Yet we talked about 90%, 600%, etc. How do those things add up? How do they add up? Sorry, either of you.
So the ones with the high returns do not get the capital they need, so they're not taken out in the
Right. So the point is that the capital is going to firms which have low marginal product. It must be the case that there are tons of firms which have low marginal product and they are getting the capital. That's the only way these two facts add up, is that the capital must be flowing to the ones which have low marginal product. Otherwise, you cannot have these two facts. We're not doing deep economics here. This is just almost arithmetic. You can't have an average which is 22% and lots of things that go into the average which are more than 22% without having a bunch of them which are less than 22%. So there's a bunch of firms. In fact, a very large part of capital must be flowing to firms which have less than these high rates of return we observe from the experiments. The small firms seem to have very high rates of return, but they're not getting a lot of capital. The capital is going somewhere else, and there the returns are not that high. What does that say about aggregate production function? Did you have something? It doesn't exist. The aggregate production function doesn't exist because we need to absolutely know who's getting the capital. The marginal product is not equalized. We just said that the marginal product is not equalized, right? We just said that, the marginal product in some firms must be much higher than that in others. So the aggregate production function doesn't exist. So prima facie, it doesn't exist. Now, just one second. I'm going to come back to trying to say something about what that means for. So let me just say two things, and I'll remember. One is, that doesn't necessarily mean. What I showed you is that there are some instances of where the marginal products are not equalized. I didn't show you that adds up to much. Does that matter? So maybe there are 3 firms which are very high marginal products. There are other firms which are all equalized, but 3 happen to have very high marginal products, or it's all measurement error. So does it matter? So that's first question. Second, so that's something we're going to look at. Second question is, what does this mean for the macro policy question? If I wanted to invest in this country, could I find those firms? So it's not simply that the challenge in thinking about macro policy is that there might very well be firms which are very productive, but do we have a technology for finding them? Because if not, it's useless. Otherwise, I just scattershot dump the capital somewhere and it has this average return. So is there a way to find it? I'll say maybe next time I'll take a little bit of time to talk about finding them, but let me park that question for now. But then I want to go back to the question of what I do want to talk about is, does this matter? Does it aggregate to something big? Is it the case that there are few firms with high marginal products and everybody else is equalized, or does this have large consequences? And is there a way to look at that? That's the question I'm going to spend some time on. Is it clear what the puzzle is? The puzzle is we know that the marginal products are not equalized, but does it matter? Okay.
To ask, I think when you ask this question, is there such a thing as an aggregate production function? You mean more than how? Is it the case that capital markets are competitive?
I mean a little bit more than that. I mean all factor markets are perfect. If I showed last time that there is a theorem which is that if all capital markets, all factor markets are perfect, an aggregate production function exists. That's a theorem.
So it's equivalent? Yeah, two equivalent questions. I was asking if this is the same question.
It's the same question, but not just for capital markets, for every factor market, but then they are exactly the same question. Not exactly the same question. Aggregate production function is a sufficient condition for the existence of capital perfect of an aggregate production function is that all capital markets exist. And you had a okay.
Yeah. But when we still construct the production function and we find A as the residual, cannot we say something about it? Like the A measures the misallocation?
We don't know whether the A measures a misallocation or differences that are across all firms. It aggregates the two, right? I mean, we're going to try to do exactly that exercise right now. I'm going to show you a very nice attempt to do exactly that. They aggregate these into a production function. So let me come to that. That's yeah.
Well, I was thinking whether this problem can be considered a contract theory problem, because if your productivity firms are not getting very high returns, maybe it's because it doesn't exist an optimal contract between the private.
Absolutely, but I assume that Esther spent quite a lot of time talking about exactly that. So I'm going to skip that part. I don't want to explain why the marginal products are not equalized. That I assume was already covered. I don't know, some of you must have been in Esther's lectures. Yes? And it was covered, right? So I'm going to skip that part. So whatever the reason she's already talked about, I'm not going to talk about it since I don't have 16 lectures, so I'm going to skip that. Okay, let me do a little bit of background and then jump in to this last exercise I want to do, and I'm going to go a little fast through this. This is actually unfortunate because this paper is a little bit, I think it's understanding what's in the background of it is actually useful, and it's a little dense, and I thought I could actually help you read it, but I might I'll see how much I can do, and if not, I'll continue next time. Okay. So before that, let me just so there are sort of, we already talked about, it could be that the TFP in all the firms, some reason firms may not optimize. There's one general problem that I'm going to skip completely is that firms are not optimizing. Because if firms are not optimizing, you could get anything. Okay, so I'm not. There's one piece of this which is, so I'm going to assume that firms optimize. So there's always behind all of this, and I'll come back to that at the end, the question of do firms actually optimize? Because it's a very interesting question. Perhaps the cutting edge of a lot of research needs to be there, but it's not something that I'll say anything about. So I'm going to skip this point, which is there's a productivity effect, which is inefficiency across the board. Firms are not optimizing. Then it might be that within the class of firms are still optimizing, two things could happen. One is, I'm going to draw a production functions here. First possibility, K, Y, is that here's a production function. and some firms are here, the high marginal product, some firms are here, low marginal product. What I really need to do is take these and bring them both here, equalize them. So some firms are too small, they have high marginal product. Some firms are too big, they have low marginal product. I should take all the capital away from the big ones and give it to the small ones. Or I could draw a production function where the opposite is true. I could draw a production function which looks like this, where these firms have low marginal product, these firms have high marginal product. I should take the capital from here and give it to them. That's one possible source of inefficiency. A second source of inefficiency is here's one production function, here's another production function, and let's say these two firms have the same amount of capital. This one has a much higher marginal product. I should just take the capital from this firm and give it to this firm. The better firm should have more capital. Maybe they have the same capital, or maybe the better firm is smaller than the. So there are two separate sources of inefficiency, and these two, in a sense, I'm not going to try to distinguish between right now. In this particular paper, it doesn't try to distinguish between them. It throws out this one. It assumes that the firms are optimizing. Given their resources, they're optimizing, and that's not. I think in the end, I'll try to persuade you that that's not obvious at all. I'll come back to that next time. I'm going to skip this. This is all stuff. This is just why could this happen, and you've sort of seen some of it, so I'm going to skip this. So this is Shea and Klenow in the American Economic Review. So I think a very nice paper, very, very, as I said, dense. And I'll try to expel out what they're trying to do. So some of it is just boilerplate, and you get used to it once you do macro. One is to say that they want to have, so top level, there's one final good. One final good is called that GDP. GDP is produced by combining a bunch of individual goods which are indexed by S. Okay, so this is GDP is some Cobb-Douglas of those, and this piece of it is not that interesting. They're not going to make any use of it, so you don't have to worry about it. Intermediates are produced by further intermediates. So think of this as being steel, and steel is produced by a bunch of different producers, each of whom produces a slightly different variant of steel, and or in different locations or whatever. There's some product variation, and this is a CES production function, constant elasticity of substitution production function. And then the YSI are produced by a production function which just uses labor and capital. The entire exercise they're going to do is to try to just focus on within S variation. So firms that are within the S, a single S sector, are their marginal products equalized? What are they trying to, what will they deliver? We know they're not equalized. What they're trying to do is try to do the exercise we said somebody should do, which is to generate a properly weighted average of those distortions. So we know that there's some distortions. Some firms that have high marginal products, others have low marginal products, but maybe those are rare. Can we get a sense of how far are we from the equalization of marginal products, and how big an effect does it have on GDP? So they're going to actually try to deliver an answer which is of the form, this is the magnitude of the effect on GDP. Okay, so that's the ambition. That's why this paper has been incredibly successful, because it's a paper that suggests that you can do something, that you can take these micro distortions and add them up and they're suggesting a way of adding it up. They have to make a lot of assumptions to do that, and I don't love many of the assumptions, but you have to, it's enormously useful to do the exercise, to kind of hold your breath and keep going. My inclination, speaking for myself, is always to say, oh, but that's not quite real, so let me do something more complicated, but then you can't keep going. What they do is they make a set of simplifying assumptions, but then they can keep going all the way and deliver an answer. Okay. So they basically, this is everything I've said here. The one thing that this formulation does is they make these YSIs are not perfect substitutes. They have a CES production function. Why do I not want to make them perfect substitutes? Because if I made them perfect substitutes, then the best firm, the most productive firm, which may be one that's not the best, but the one which has the biggest advantage in the capital market or the labor market, there could be, I'll come back to those things, but for whatever reason, one firm will dominate the industry. It will have 100% of output if they're perfect substitutes. And then you cannot look within the industry at how much variation there is in that model. Since they want to look at within each S industry, how much does the marginal product vary? To do that, you must have many firms in that industry, even if they have different levels of efficiency. Inefficient firms have to survive. How do you make them survive? You make them survive by making them imperfect substitutes. So and that's not an assumption I love, I must say, because I think many of these industries, as I was saying, they're all producing shirts. Those are probably perfect substitutes. So it's hard to imagine that that's exactly what's going on. But I think that's needed to do the exercise they do. You need some form of imperfect substitution. Okay. Second, they have a model with two distortions. One is the cost of capital varies at the I level. This is the markup. Everybody has a basic price R, and then you have a markup on that. This is the extra you pay if you are firm I, which could be positive or negative. This is the markup on the price of the final good you sell. Again, this could be positive or negative. It's just an extra amount, and you can think of these as being taxes that the government imposes in each firm, but they're probably not taxes. They're probably something else. They're coming in from the capital market, from the labor market. Now, why is there no tax on labor here? Why do they assume that? Sorry?
Mobility?
No, it's a more elementary answer.
Then you count this entanglement between
Yeah, there are only two in a maximization problem. What matters is the price relative to the wage. So you can't. So once I have the price varying, I can't also have the wage varying. There are only two parameters that are free. Okay. Then what they do, and I'm going to not go through the algebra because that we don't have time for, is to write down an expression for profits. This is profits. This is the value of what you sell. This is how much you pay in taxes. This is your wage. This is how much you pay on capital, and this is. So this expression should make. If this expression doesn't make sense to you, then I have said something wrong. But it should immediately make sense to you. And then what they do is. So what they're doing is they're allowing firm level differences in marginal product here. Why? Because they are allowing these numbers to vary at the firm level. So firms are equalizing their marginal product to a price, but the price is not the same for everybody. Different firms face different prices. Okay, so then what they do is they, if you maximize this, which then by choosing YSI, which is how much to produce. When you do that, you get an equation which looks like this. And then they write it in this form. All that I want you, this you should check that you understand it. I think I copied it directly from the paper. I think I copied it correctly, but you should check it because it's actually kind of good practice. But the important conclusion they draw from that is that you have some relationship between the total revenue of the firm and its output, and the J doesn't depend on the firm. It's a constant. Okay, why is that useful? Well, then this is total revenue, this is total, and then this is your average cost, this is your output, and you're maximizing the difference between that. This is total revenue. This is just from the previous slide. This is total revenue. It's not so surprising. It's some increasing function typically of your output, and this is your cost, and you're going to maximize the difference. What that does, it gives you this relationship. And this comes from the CES assumption. It's extremely convenient, but it's very important for what they do. I'll point out where it's important. So in other words, the cost is a fixed fraction of the revenue. The CES assumption gives you that. This is super important. It's a standard. This is very standard. It's a fixed markup. Basically, this says there's a fixed markup on the cost. Revenue is just 20% more than cost. This is a very standard assumption. In almost all trade theory does this now. So it's nothing strange about it, but it is very important for something I'm going to point out in a minute. And this ugly slide is where it's going to happen. But I want to actually not have you focus on the slide so much as, well, actually, maybe I say I'm wrong. You should focus on it for 1 second. So this is the marginal product of labor has to be equalized to the effective price of labor. Effective price of labor is the price of wage divided by the price of output. Basically, the price of output is distorted by this amount. So this is what the marginal revenue product of labor, meaning in terms of money. So another way to say it is that if I multiply this by this side, I get the wage. That says that every unit of labor in terms of money generates this much money. And then the government takes out, or whatever, the distortion takes out this much of it. So that should be obvious. Here's what is very much comes from the Cobb-Douglas assumption. Remember, the production function for individual SI is Cobb-Douglas and capital and labor. The Cobb-Douglas assumption gives you the fact that the average product is proportional to the marginal product. That's what Cobb-Douglas does. This is the average product, the average cost and of. So what you have as a result is that you can write the marginal product as, so we made two assumptions. One is the Cobb-Douglas, and the other is this piece. This piece is total cost is related to total revenue. So what Cobb-Douglas does is says that I can think of, I take the total cost, a fixed fraction of it goes to labor. And the second, that the marginal product of labor is proportional to the average product. And the third fact is that from the CES assumption, a fixed fraction of the cost of the total revenue is the cost. That's what we had last time. Put these two assumptions together and you get this line here. This is all you really need to understand. Is here what we've had is turn the marginal product into the average product. This is the average revenue product. Price times output, that's the output divided by the amount of labor you put in. So this is the average product. So what I've done is I've taken the marginal product, which nobody knows. It's not in the data, because to get the marginal product, I need to vary the input and see what happens. The average product, of course, I observe in the data. In the firm level data, I know that they produced 100 units of output with 10 units of labor. I divide the two, I get average product. So all of this goes, all the structure in the paper goes into generating this relationship, which is that I can take the marginal product and replace it by the average product. That's everything in the paper. So once you got there, you're done, because the average product you observe in the data. Now, we know that the average product is typically not proportional to the average marginal product. That's the problem. Keep in mind that that's the problem. I'll give you an example next time. But right now, just keep that in mind, that what we've just done by all these assumptions is we've turned this equal to proportional to this. And now we're going to try to look, remember our whole point was to look at variation in marginal product. What I've just done is I've turned it into variation in the average product. The average product is easy to measure. I'm going to go to firm level data, measure the average product, and then I'm going to see if they're equalized. Now, in general, those things are not linear in each other. That's the problem that they're solving. So all the math in the paper goes into generating that. Can I use average product? So CES, Cobb-Douglas, all this structure goes into, it's quite clever, because you need to find your way to it. But once you find your way to it, what they then do is they define something called TFPR. TFPR is price times what we usually call TFP, which is this A term. Okay? That's equal to that, price times output divided by inputs, using the Cobb-Douglas. Okay? This comes from the Cobb-Douglas. But then I can take K, I can invert this equation, and I can write this. Remember, this is a function of L, and I can write this as a function of this thing. I could invert this equation and write L as a function of that. I can invert this equation and write K as a function of that. Plug it in here. So what this expression is effectively, it's, once you see that, you'll see that what they've done is basically they have turned this into a function of just the differences in the average products. Because they plugged in, they made, this is the average product, they invert this equation, so they're just making, this is really almost exactly the same thing as the difference in average products. Okay, let me make one more observation, and then actually I have to continue next time, but I think this is a useful place to stop and for you to understand. And it's on Friday, so we can continue, I think. So let's take this expression. PSI YSI divided by KSI to the alpha LSI to the power of 1 minus alpha. And these are alphas have S on it, but let's forget that, it's not so important. I can write this as equal to PSI YSI divided by KSI to the power of alpha PSI YSI divided by LSI to the power of 1 minus alpha. This is exactly equal to that. All I've done is I've broken the numerator into two things that multiply into PSI. Do you see what I've done? This times this is that. This is the average product of capital. This is the average product of labor. So this thing that they're defining is just the product of those two, the average product and the marginal product. That tells you that if there is no distortion, and we know that these numbers, this is proportional to marginal product of capital, this is proportional to marginal product of labor. Yes? But then we know basically that if the marginal products were equal in every firm, what can I say about this number, TFPR? If marginal products were equal everywhere, which is what aggregate production function requires, what would I say about TFPR? This number, which is this number here. They'll be equal. TFPR must be equal across all firms if the marginal, it's exactly 1-to-1. It's just a product of the marginal products. This is just the average product. We just argued that their main trick is to make the average product proportional to the marginal product. If the marginal product is equalized, the average product is equalized, and you're home. So in other words, this whole construction is basically turning this number, which looks like a mysterious number, until you understand what they have done is they have constructed a product of the two things we care about. The two inputs, the marginal products of those inputs should be equal. If they're not equal, then something is going wrong. And we can look at that by seeing if TFPR varies across firms. Because TFPR is just the product of the things that should be equal, but if they're not, TFPR will vary. If not, if they're all equal, TFPR would not vary.